Good morning. Today we are going to continue with our investigation of kinematics, and specifically we're going to look at the Earth and gravity. So there we are in our table of contents. We're going to look at gravity. So let's commence operations. For those of you following along in your notes, please turn to this page now. The Earth and any object that has mass attracts other objects that have mass. This attraction is referred to as the force of gravity. We'll discuss forces in the next unit. For now, we're just going to investigate the impact the Earth's gravitational attraction has on the movement of objects. In the absence of air resistance, all objects, regardless of mass, accelerate toward the Earth with an acceleration due to the Earth's gravitational attraction, that is this value here, negative 9.8 meters per second squared. U stands for up, which is the same as 9.8 meters per second squared, and the D stands for down. I really want to unpack this statement because it's really an amazing statement that people take for granted. So what does this mean? No air resistance, no drag, all objects regardless of mass accelerate towards the Earth at the same rate, 9.8 meters per second per second. So imagine we had a 1 kilogram object and a 5 kilogram object. And you could do this experiment for yourself. Just take two objects of different mass, but with enough weight. And imagine we drop these objects from the same height. Well, according to this statement, all objects regardless of mass accelerate toward the Earth at the same rate. If we drop these two objects from the same height, even though they're different mass, if there's no drag or no air resistance, and for a heavy enough object dropped from a low enough height, that's the case, then they'll hit the Earth at the same time. Now, in this picture, you can see feathers and a bowling ball, and these feathers and bowling ball were dropped from the same height. Clearly, the bowling ball has much more mass, except they were dropped in an area which did not have any air in it. All the air was removed, so there was no air resistance and there was no drag. And indeed, when you can have this situation, a lighter object and a heavier object will accelerate at the same rate, 9.8 meters per second per second. You can find this video by Googling the following: Brian Cox visits the world's biggest vacuum. And you'll find the video. It's a beautiful video showing the effect of removing air on falling objects. If you can remove all the air so that there's no more drag and no more air resistance, then feathers and a bowling ball, when dropped from the same height, will hit the ground at the same time. I suggest you check that out. So let's now look at what this value means. This is something that students get confused about. The question always comes up, well, when do I use negative 9.8 meters per second squared up, or when do I use 9.8 meters per second squared down? Well, first off, I just want you to recognize that these numbers can be written in this manner. There's many different ways of writing the same number, and they all mean the same thing. 9.8 meters per second per second. It's the same as 9.8 meters per second squared down. And it's the same thing as 9.8 meters seconds to the negative 2 power. In addition, these values mean the same thing, but they're just used in different circumstances, in different situations. So let's explore the two different situations. So imagine you have this character standing on top of a very famous tower. And the character decides to drop a ball. So first off, you have to ask yourself, when you're dropping an object, what is its initial speed? Well, the initial speed is 0. Now, if you really understand what 9.8 meters per second means, remember it's an acceleration, and we discussed this in a previous video. If you really understand what 9.8 meters per second means, then 1 second later, you know what the speed is. 1 second later, the speed has to be 9.8 meters per second. What does this mean? It means for an object that's falling down, every 1 second, its speed will increase by 9.8 meters per second. So in a situation when an object is falling, we would use this value for the acceleration due to gravity, the downwards value. 2 seconds later, what would the speed be? If you just understand the unit, really in physics, try to focus on what the unit means. It makes physics that much easier. You don't need any more equations if you understand the unit. Every 1 second, the object's speed increases by 9.8. Well, if it was previously 9.8 and it increases by another 9.8, the new speed will be 19.6 meters per second. So for objects moving downwards, we use the positive value, 9.8 meters per second, because gravity causes objects to speed up. Now, the one thing I didn't mention is we're assuming there is no drag and no air resistance. If there's drag and there's air resistance, then it's a different story altogether. Now let's look at the opposite situation. Imagine we have a person who wants to throw an object upwards. Well, in this situation, when you throw a ball upwards, we know it's not going to speed up. We know it's going to slow down. So we use negative 9.8 meters per second up to describe its motion. So I just picked a random number. Let's say that we throw the ball upwards with a speed of 30 meters per second. And we're going to throw it straight up. And now we're going to ask the same question as we did before. 1 second later, what would the speed be? Again, if you go back to the previous video and recall what the negative means, this means that every 1 second, the object's speed will decrease by 9.8 meters per second. So if it starts off with an initial speed of 30 meters per second, and every 1 second it slows down by 9.8, well, 1 second later, the speed is going to be 20.2. 30 subtract 9.8. And another second later, 2 seconds later, the speed will be 10.4. 20.2 subtract 9.8. And another second later, well, you can figure that out. It's almost going to come to a stop. This value for the acceleration due to the Earth's gravitational attraction is only valid near the surface of the Earth. So what does that mean? Well, if we have an object near the surface of the Earth, its acceleration due to gravity will be 9.8. However, if we move this object now at a distance of 6,400 kilometers, which is about the radius of the Earth, notice the value of acceleration due to gravity drops significantly. It's now only 2.4. It's not 0 though. There's a misconception that in outer space there is no gravity. That's not true. There is still a significant amount of gravity. It would still fall towards the Earth. If we release this object, it would still fall towards the Earth, but it would be accelerating at a lower value of only 2.4 meters per second squared, compared to 9.8 when we're close to the surface of the Earth. So keep that in mind, that this 9.8 value only is valid near the surface of the Earth. Now for the International Space Station, it orbits at around 400 kilometers above the Earth. And the value there is still significant as well. It's not 9.8, but it's 8.7 meters per second. It's still significant, the acceleration due to gravity. And again, Sometimes you'll see videos of the astronauts on board the International Space Station, and they'll look like they're floating. You'll think, oh, there's no gravity out in space. That's not true. If you take a grade 12 course in physics, you understand why the astronauts look like they're floating. The Earth's acceleration due to gravity at 400 kilometers above the Earth is still significant at 8.7 meters per second. For objects that experience air resistance, the acceleration of the object while falling will be lower than g. Will be lower than 9.8. So keep that in mind. In everyday life, for example, you see a leaf falling from a tree. It's experiencing drag, and clearly it's not accelerating at 9.8 meters per second. On the moon, objects also experience gravitational attraction due to the moon. However, the acceleration due to the moon's gravitational attraction is much smaller than that of the Earth. And again, if you're going to take a course in physics in the future, a grade 12 course or a senior course in physics, you'll understand why the acceleration due to the moon's gravitational attraction is smaller than that of the Earth. I'll give you a hint. It has to do with the size of the moon and its mass. All right. Hope you enjoyed the lesson. Have a great day.